So this is actually the question from yesterday. It's the same sequence, 5, 8, 3. And yesterday, the question was asking you to find the 23rd term. And right now, I'm asking you to find the 100th term. Why did I make that change? It's really because, I know you can just add 3, add 3, add 3, add 3, and you can get to the 22nd. I just want you to realize, as we study like longer sequence, it becomes impossible for us just to simply add, because when we get to 1,000 terms, 10,000 terms, 1,000,000 terms, that's impossible for us to do the addition anymore. So how do we approach this? So let me write it down here. So we have 5, 8, 11, and so on. If you don't mind, I can write another 2, and so on. So to study this or to solve that question, I'm gonna mark every term in this sequence. So this one, I will say this is our first term. I will give it a symbol. I will say this is A1. This is our first term. So this is not like anything special. I just give it a symbol. I say this is our first term. I use the symbol. I say this is A1, and I say this is A2, and this is our A3, and this is our A4, and this, I say this is our A5, and it gets to, we are looking at hundreds, right? We don't know what is that, but I say this is gonna be our A100, right? So this is what I do, and I think you can see I'm just naming them. I'm just giving them a name, so there should be no problem, right? And what is the common difference we see here? I think it's, you already know that it's 3, 3, 3, 3. So the common difference is 3. And I am also giving the common difference because I cannot write down common difference, this long word every time. So I just give it a simple, I say, okay, D. D means common difference. So I am naming the terms A1, A2, A3 until A100. And I am naming the common difference D. All right, so I'm just giving them a name. And next, I'm going to write down our A1. Our A1 is 5. And what about A2? A2 is 8. But I'm not going to write it as 8. I say this is 5 plus 3, right? Because it starts from the previous term. It adds a common difference. It adds 3. And the third term, I say it's 5, and this is 11. So it's 5 plus 3 and plus 3. So I'm going to write it as 5 plus 2 times 3, because it starts from 5 and then add 3 twice. And A4, it's a 14, but I'm going to say this is 5 plus 3 times 3. 3 times 3. And our A5, the fifth term, I say this is gonna be 5 plus 4 times 3, right? Because the result is just, the first term is 5, second is 8, third is 11, fourth is 14, and fifth is 17. So I'm writing it this way. And now I want you to observe all these terms here. I want you to see what changed and what does not change. So what changed? Of course, these things change, right? These 1, 2, 3, 4, 5, they change that because they are different terms. And what else? What else changed? You can see, okay, there's 2, 3, 4. So this change, this change, this change, this change, and this is changing. And the others are not changing. The 5 is not changing, and the 3s are not changing. So I want you to compare between the 3 and 2, between the 4 and 3, between the 5 and 4. What did you see? What's the relationship between the 3 and 2, 4 and 3, and 5 and 4? Can anyone share with us? What do you think? What is the relationship between them? What is the relationship between 3 and 2, 4 and 3, 5 and 4?
The opposite one?
So you mean the difference is 1, right?
Yes.
So as you can see here, this number is always 1 less than the term. So 2 is less than 3, 3 is less than 4, 1 number less, 4 is 1 less than 5. So based on this observation, can anyone make a prediction as to what will be the 6th term? What will happen for the 6th term?
5 times 3.
5 times 3. And is there anything else? That's
Plus 5.
all? Plus 5. Thank you. Plus 5. Because we say that plus 5, it does not change, right? So again, as you can see here, this 5 it's not changing. This 5 is not changing, and this 3 is not changing. Only change is this and this. And what changes is this number is 1 less than the number of the term. Okay, and I think you can see if we go on, we can see A7 will be, this won't change. This 5 and then plus 1 less than 7 is going to be 6 times 3. 6 times 3, right? So I can go on and on, but I think we don't need to repeat ourselves. But now let's jump. Let's make a big jump. It's going to be a leap, a 100. Can anyone go ahead and tell me, how do I write the A100? How do I write the A100? Go ahead and tell me. A100 will equal to what?
5 plus 99 times 3.
5 plus 99 times 3. Okay, we have an answer here. Now, I want everyone, let's get a quick vote. Quickly, do you agree with that answer or not? Right, we all agree. That means we find how to get the 100th term. Now, I'm gonna challenge you. How about 1,000th term? Anyone? 1,000th term.
5 plus 999 times 3.
999 times 3. Cool, you're totally getting this. Then what about, let me get it crazy. 7, 8, 9, 2, 5. This 78,925th term. Anyone can tell me?
5 plus 78,924 times 3.
Yeah. I guess you're right. So basically, you see it. Now, let's review. How did we get here? We get here by writing down the 1, 2, 3, 4, 5, and we see the pattern. The pattern is something don't change, and only 2 things change. And their relationship is this number is 1 less than the term. So now I want to further challenge you. I'm not giving you a specific term. I will say, okay, I say this is the nth term. Nth term. Okay, that n can be anything. Like n can be any number, so any term. I want you to tell me, if I need to know the nth term, is there a way for me to figure out? Think about that. This is gonna be a big leap for us. Because right before every term, be it 100, 1,000, or 78,000, anything, they are decided. We know we are looking at this term. But what if like I'm talking about any term, nth term? Is there a way to figure out? Think about that. So we'll still, let's see, because we know something don't change, right? This 5 won't change. So can I write this 5 down? Because I know it doesn't change for any term. It doesn't change. It still be the 5, right? And also, we know this 3, it doesn't change. So can I write it down? And this something times 3. And these things, they don't change. So I can write it down. And I only need to know this part, right? This part. What about this part? Would this part be 1 less? Would this part be 1 less than this one?
Yes.
So how do you describe this part? How do you describe this part? This is n, and this is 1 less than n. How do you describe?
-1 in parentheses.
N what? Can you say that again?
You put n-1 in parentheses.
n-1. I like that. n-1 in a parenthesis. So could this indicate this number is 1 less than n? I think so, right? Because it says n-1, so of course it's 1 less than n. And let me just erase these parts. This green, this green, this green, this green, this. Okay, I take this out. And what do we have? an, nth term equals to 5 plus n-1, then times 3. Will you agree or not agree? So quickly, let's have a vote. Let's have another vote. Okay, I will be okay. Let's start a new vote. True or false? Okay, let me know. True or false? That expression, that formula that we just got. Is it true or false? Okay, let's take a look. So we have most of us thinking it's true. It's true. Okay. 1 or 2 think it's false. If you want to go ahead and talk to us, like why do you think it is false? Yes, you can turn on your microphone and talk to us. Like if you don't agree, you can talk to us. So maybe you changed mind. All right. So just know, like whenever you have a doubt, you can always speak out. All right. So let's go back here. Let's go back here. So we have, this is actually a formula. This is actually a formula, as you can see here. This is actually a formula. And how did we get here? By studying the first, second, and third term, and by studying what is changing and what is not changing. So we know these two are changing, and these 5 and 3 are not changing. So, and by studying the relationship between the changing parts, we say, okay, we have for nth term, this part is 1 less, so this is going to be n subtract or -1. We're almost done. We're almost done. So what about the 5 and 3? What about the 5 and 3? Like, what are they? Why is it 5? Why is it not 6? Or why is it 3 not 30? So let's go back and look at our original sequence. What is 5 there? When we start says A1 equals 5, what is 5? 5 is actually the first term, right? 5 is actually the first term. And what is that 3? That 3 is the common difference. That 3 is the common difference. So if I say an, that 5, I'm saying this is the first term. This is the first term. And I can write it as this. I'm just replacing the 5 with our first term. And, you know, we begin with that. We say the first term is 5. So now I just use the name, use a symbol to represent that. So I should be fine. And this 3, this is our common difference. And why? Because I'm just adding the common difference every time. So this is our common difference. So I can further write this as A1 plus times our common difference. Our common difference. So this is our formula. This is our formula. So we are doing a little jump here. So let me know. I want to check with you. How do you feel right now? Like when I go from the last thing to here, let me know. How do you feel right now? How do you feel? Because we're jumping from that n subtract 1 to suddenly we have a A1 and then a D in the formula. So let me know, how do you feel? Okay, in this jump, some are a little confused. Some are a little confused. Okay, I see. Thank you. Let's go back. So we all agreed here. You know what? We can forget about this right now. Okay, we don't need to just jump here. Okay, let's just forget about this. Okay, let's just stop here. The nth term is 5 plus n subtract 1 and times 3. Okay, now let's go back to the this question. This is a number 8 question yesterday. This is number 8. So let me copy it down there. Okay, so this is yesterday's last question. Which formula can represent the pattern of the sequence? The pattern of the sequence. So let's use the method we did today. So we have 2, 8, 14, and so on. So I'm going to say this is our A1, A2, A3. And what is our common difference? What is our common difference? So here, the difference 6. The difference is 6. So our common difference is 6, right? And now let's write down. Let's write down our A1 is a 2. Our A2 is, I'm going to write it in the form of 2 plus 6. I'm actually adding the common difference here. This 6 is actually the common difference. And then my A3 is 2 plus 2 times 6, because going from the first to the third, I'm adding the common difference twice. So I'm adding 2 times of the common difference. So I hope you can see here, this 6 I'm adding, that is actually, this is the D, the common difference. This is the common difference. This is a common difference. And as I go on, A4, that will be 2 plus 3 times 6. And again, this 6, this is also the common difference here. So what we are doing is we are adding common difference to the first term, So this thing, this is our first term. This is our first term. This is our first term. And this is our first term, right? So we are just adding difference to the common difference to the first term. And what's changing is just like how many times are we adding the common difference. So again, as we go ahead, A5, it's going to be 2 plus 4 times 6. 4 times 6. Again, this is our first term. And this is our difference. This is our difference. This is our difference. So if I'm just replacing, I'm not using the 2 and I am not using the 6, our formula should look like A1 equals A1. A2 equals to A1 plus a D. A3 equals to A1 plus 2 times D. A4 equals to A1 plus 3 times D. And A5 equals to A1 plus 4 times D, right? Because every 2 here, that's actually the A1, and every 6 here, that's actually the D, the common difference. So I am actually writing it like this. A1 is A1, A2 is A1 plus 1D, A3 is A1 plus 2D, A4 is A1 plus 3D, and A5 is A1 plus 4D. And this D, I can actually write it as 1D. This is 1D. And this is A1. I can say this A1 plus 0D. 0D, because 0 times D is nothing, so the result is the same. And now we can see A1 is always there, D is always there. A1 is always there and D is always there. And what's changing is just 1 minus 1, 2 minus 1 to have this, and 3 minus 1 to have this, and 4 minus 1 to have this, and 5 minus 1 to have this. The only thing changing is the term and this part. So let me write A6. So A1 is still there, and it's actually 6 subtract 1 then times D. Well, we know it's 5, right? So A7 is going to be A1 plus 7 subtract 1 then times D. A8 is going to be A1 plus 8 subtract 1 times D. And ultimately, if we jump to any number, An will be A1 plus n subtract 1 and then times D. We know that A1 is 6. A1 is 2. So A1 is 2 and plus n minus 1 subtract d, and d is a 6, right? If we actually put the a1 and 6 back, and then we have this. And then let's simplify this. This will be an equals 2 plus the 6 times n, 6n, and then minus 6. And that's going to be 6n subtract 4. 2 subtract 6 is negative 4, right? So that is the answer. That is the answer, 6n subtract 4, subtract 4. But again, you know, this part, I don't need you to actually remember. What I'm asking you to learn and remember today is this. How did we get this? This is our formula. This is our formula. So if we have a similar sequence, so we can just put in, as long as we know the first term and we know the common difference, we can instantly get the formula. We can instantly get the formula. So let me write down that 2, 8, 14, and da. So we know A1 is 2, and the common difference is 6. So put in to the formula, AN will equals to A1, that is 2, and then plus n subtract 1 times d, and then you have the formula. You will be able to instantly calculate a hundredth term. So n is a hundred. A hundredth term is going to be 2 plus 100 subtract 1 times 6. And a thousandth term is going to be 2 plus 1,000 subtract 1 times 6. So this is actually, again, I don't want you to remember this. I only want you to remember this. All right. So we just did a little bit more. We did one more example. So I hope this helped a little bit. So that is the sequence formula. And this formula, I put it in the slides. So you can always come back. An arithmetic sequence has a common difference. So not every sequence has a common difference. This formula only works when there is a common difference. So the formula is nth term equals to A1. So here it says A. Actually, this is the first term, so it says A1 plus n subtract 1, then times the common difference, Okay, so again, this is new. This is a big leap. Okay, so if you feel confused, that's natural. We will have time to, continue work on this. So last thing, I want you to answer the 3 questions. So first, what is the A1 in this sequence? And what is the common difference D in this sequence? And I want you to try to establish a formula for the nth term in this sequence. Okay, let's try this. And meanwhile, I will be doing our attendance again. Establish a formula. Yes, it's the nth term, so it should be an equals 6 plus n minus 1 times. Okay, this one, why do you have a 2 plus? We don't have a 2. Remember, your first term is a 6, right? So there's not a 2 there. Yes. 6 plus n minus 1 times 5. 6. Yeah, good. an is 5 times n. Think about that. This number should be 1 less than the n, right? So what should you multiply? It should be 1 less. It should be 1 less. The first term in the sequence 6. It's 6. First term is 6. It's not A6. A6 means the 6th term, the number 6 term. Common difference 5. So an is 5. 6 plus n minus 1 times 5. First term 6. Common difference. Good. 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 First term is 11. Check again. First term is not 11. What is the first term? 6 plus n minus 1 times 5. 6 plus n minus... someone says the common difference is 6. Really? Check again. The common difference. Okay. So quickly, really quickly. So let me okay. Really quickly. Oops. So this is our A1, and the common difference is 5, right? So our common difference is 5. Okay, you got to be clear about that. A1 is 6. Common difference is 5. And the formula, so it's going to be our first term plus n subtract 1 then times the d. Since a, the first term is 6, and the d is 5, so it's going to be n subtract 1 times 5. All right. Okay, class. I hope you you have better idea about how to get the formula. And again, if you feel a little confused, go back. I'll be posting our sketchbook, and the slides are in the Google Classroom. Go back, review. All right. So thank you all for your attention. I think we had a great day, and I'll be seeing you tomorrow. Bye-bye.